100, lab number 21. We're going to take a quadratic. We're going to talk about which direction it opens on the graph, its vertex, the domain, the range, its increasing and decreasing intervals, its y-intercept, and its x-intercept, and then we'll look at the graph on the graphing calculator. All right. So with this particular function, we have A, B, and C there, just like we were using for quadratic formula, vertex form, and all that things. So, the A determines which direction it opens. If A is positive, then the parabola would open up in this direction. If A is negative, it opens down. Here, A is -2, so we know that this opens down. Okay. And then the vertex we find by using the formulas that we did in lab 20, where x equals -b divided by 2a. So in this case, it'd be -12 by 2 times -2. So the x value of the vertex is going to be -12 divided by -4, which is 3. And then to find the y value of that, we're just going to plug in 3 for x into the problem. And then work that out. So that'd be 9 times -2, -18 plus 36 plus 3. So that's 36 minus 18 is 18 plus 3 is 21. So 321 is the vertex. The domain for quadratics is from -infinity to +infinity. The range is dependent upon the vertex, the y value of the vertex, and which direction the parabola opens or the quadratic opens. Since this one opens down, the range is going to be from 21 or from -infinity to 21 is the way that we would write that. So we're going to read from bottom to top. And we include the 21, so we use a bracket. The increasing and decreasing function, so we know the graph looks something like this when we draw it. It looks something like that, okay? And right there is the vertex at the top. So the increasing interval is from -infinity up to the x value of the vertex, so 3, because it opens down. And then the decreasing interval is from 3 to +infinity. That would be the right-hand side of the graph. Okay, so this is decreasing, this is increasing. Okay, and if it opened up, then you would reverse those two. Okay, now we want to find the y-intercept and the x-intercepts of this graph. Y-intercepts are found by just taking the function and plugging in a 0 for x and working that out. Should be 0, 3. The y-intercept at 0, 3. X-intercepts, set the equation equal to 0 and solve it whichever way you feel fit. I'm gonna do it with quadratic formula. So that'd be 144 plus 24, 168. Okay, so that's a positive. So that means it has two x-intercepts, two real solutions to that equation. So we're going to have -12 plus or minus square root of 168 over 2 times -2. Okay. I'm going to break down 168. 284, 242, 7 and 6, 3 and 2. So there's a pair of 2's and then 42 left over. So -12 plus or minus 2 radical 42 over -4. We know that these three numbers are all divisible by 2. So that's how we're going to simplify. I'm going to divide them all by -2. So that gets a 6 plus or minus radical 42 over 2. Okay. Our x-intercepts would be at 6 plus the square root of 42 over 2. And x equals 6 minus the square root of 42 over 2. Now if we graph that on the graphing calculator, we could get decimal approximations for those. If we graph this on the graphing calculator, we hit y equals to get to this menu. And then we're just going to type in the equation at negative 2x squared plus 12x plus 3. And then graph that. I'm going to zoom out just a little so that we can see the vertex of that. So we see it's opening down. The vertex, this point right here at the top, would be that 321 that we had found for the vertex. I believe that's the right numbers. 321. And then our x-intercepts, 6 plus the square root of 42 over 2 would be this x-intercept on the right. This would be the x-intercept on the left. So get those things. That's what the picture looks like for lab 21. That's the things you want to find.